This time we're going to look at determining surface area for a composite 3D shape in a different way. So again, we're going to break it down, but this time we're going to break it down into two three-dimensional objects, and we're going to relate each one of those objects to their two-dimensional shape. We're going to determine any surface area formulas we need and also determine any dimensions that we know. We're going to calculate the surface area for each shape, multiply the surface area by the number of times the shape appears, and then add all the surface areas together in order to determine the surface area of the final shape. So our first step is to go ahead and break it up into the different 3D shapes that we actually know. The first one is a cube, which is the bottom of my house. And I know it's a cube because each one, the length, the width, and the height all have the same dimension of 6. Then I also have a rectangular pyramid that's at the very top where represents the roof of my house. So now start relating the three-dimensional object to its 2D shape. So keep in mind that there will be, where the two shapes join up, that part will be eliminated. So we have the net of a cube here, and one of those cubes will be removed. Again, because that's where it joins up with the rectangular pyramid. The bottom of the rectangular pyramid also won't be included in the surface area because it's where it joins up with the cube. So we will have those grayed out so that we will not include them in our final shape. We're going to go ahead and we're going to add the dimensions here too. So again, the cube has all of the same dimensions of 6 inches. And I only have to do it for one of the shapes because all of the squares are going to be the same. And again, because it's a cube, all of these in two-dimensional will be squares. For a rectangular pyramid, again, we're not really worried about the square that's on the inside, but we are worried about these triangles. Each one of these triangles has a height of 4. We can see that from the image right here, noting that this is perpendicular to the base, which is 6 inches. Determining any of the surface area formulas we need, again, because it's a square, each one of the sides, all we need to do is multiply them by itself. So we have side squared. And the surface area of a triangle is the 1/2, the base times the height. Again, base is the bottom of the triangle, and the height is the perpendicular line that goes from the base up to the vertex. Keeping this in mind, we can go ahead and we can start plugging in those numbers. Remember, we had sides of 6, so we can do 6 squared for the square, which gives us 36 inches squared for the surface area of each one of those squares. And then for our triangle, we have 1/2, our base, which is the bottom, so 6 times our height of 4, which gives us 12 inches squared for each one of the triangles. So each one of our squares has a surface area of 36, but we have 1, 2, 3, 4, 5 squares. So we're going to multiply that by 5 to represent the surface area for each of the 5 squares. And we have a total surface area of the squares of 180 inches squared. Then for our triangles, each having a surface area of 12, we're going to multiply them by 1, 2, 3, 4 to give us a total surface area of 48 inches squared from the triangles. So my final job is to go ahead and add these two values together in order to get the total surface area of the entire shape. And the total surface area of the entire shape is 228 inches squared. Again, I did that by adding 180 inches squared from the square components and 48 inches squared from the triangle components.